Okay guys, with this video, we are going to start discussing questions from IBMATH AASL Paper 2 of the May 2024. So section A. So with this section of the paper 2, we have to answer all questions and then answers must be written within the answer box provided and the working may be continued below the lines if necessary. And also don't forget you have to answer your questions in 3 steps. Okay, so question number 1. Okay, so here we have a student claims that the rabbits in Australia have longer ears than rabbits in Spain. To test her claim, a randomly selected sample of the rabbits was collected in each county, and the length of the one ear of each rabbit was measured, and the value recorded correct to the nearest millimeters. In the Australian sample, the median recorded value was 80 millimeter, and the interquartile range was 11 millimeter. So we can say that the median Q2 is 80, right? Q2 is also median. And then IQR, the interquartile range, is 11. Okay, so next information that we have is that we have a Spanish sample that is shown in the box and whiskers diagram. That means this is the Q1, this line is Q2, this line is Q3, and Q2 is our median value, right? So question A, we have to complete the table here for the recorded values of the length of the rabbit's ear in each sample. So Spain, so we have Australian information, right, which was given here, 80 millimeter and 11 millimeter. Then Spain, Spain's median value is this line here, Q2 line here, right? So we can say that it is about 75. And also, to calculate the interquartile range, we know that to calculate the interquartile range IQR, we have to subtract the lower quartile value from the upper quartile, right? So upper quartile, which is Q3 value minus lower quartile, which is Q1. So we can do 84 minus 68, right? We got this value from this diagram here. So we got the interquartile range as 16. Okay, then let's try question B. We have to compare the distribution of the lengths of the rabbit ears in Australia and Spain using the median values and interquartile range. Okay, so question I. So from the previous question, we know that rabbit ears in Australia has the median value of the 80, right? So the median values in Australia is equal to 80, right? And also the median value for the rabbit ears, the length of the rabbit ears in Spain is equals to 75. And from these values, we know that the Australia median value is way bigger than the Spain, right? So from here, we know that since the Australia rabbits has the a higher median value, it means in average, the rabbits in Australia have longer ears than the one in the Spain, right? Then let's look at the second question, II. So we now have to use the interquartile range. Okay, so when we compare this interquartile range for the Australia and the Spain, so for the Australia has IQR value of the 11, right? And the Spain has value 16. The IQR value is higher in the Spain, right? That means since the interquartile range value is higher in Spain, the difference between lower quarter value and upper quarter value is greater in rabbit ears in Spain. That means there is more variation or spread than those in Australia in terms of the length of the rabbit ears. Okay, so let's try the question number 2. This question has a maximum mark of the 7 points. So Darren buys a car for $35,000 and the value of the car decreases by 15% in the first year. Okay, so for the question A, since we're trying to find the value of the car at the end of the first year, what we need to do is we just have to subtract the 15% of its original amount from the original amount. So original amount is $35,000 and then we're going to subtract 35,000 times 0.15. We're using 15% in a calculation. So this is 0.15, right? So once we do this calculation, remember this is a GDC question. So you can definitely use your calculator to solve it. So when we do the calculation using the GDC, we get $29,750. However, we have to leave our question in specific. So the final answer is $29,800. Then let's look at the question B. So we got few extra information, right? So after first year, the value of the car decreases by 11% in each subsequent year. So means the first year is 15%, but after second year or the after first year, so starting second year, we know that the price of the car decreases by 11%. So interest rate is changing, right? For question B, we need to find the value of the Darren's car 10 years after he buys it, right? So for this question, we're going to use the finance app on your calculator, or we call it TBM solver, right? So using the TBM solver, we're going to set the n, the number of the years that the Darren holds the car, as 9, because after first year the amount of the interest rate changes, so we have to set n equals 9, and the interest amount that we're going to use is the negative 11% because the price is decreasing, and present value is from the question A. So we are using the price of the car after first year. So the price of the car after first year is actually solved in the question A is 29,750, and the future amount is the one that we need to find. Okay, so let's try the question B with the calculator. So I just showed you what this M means, I means, PB means, and FB means, right? So when you're plugging those numbers into your calculator, you have to follow these keystrokes. So first press F, and then press 1, and press 1, which is TBM solver. Then for the N, we're going to substitute 9. And for the I percent, which is the interest, we're going to substitute negative 11. And for the present value, we're going to substitute 29,750. Okay. PMT, we're going to leave it as 0. Future value, we're going to leave it as 0. For the PY and CY, we're going to leave it as a 1 because we are decreasing the value by 11% each subsequent year. Then once you're done this, you're going to move your cursor back to FB, which is future value, and that's what you need to calculate, right? Then you're going to click ARPA and enter. Then you got your future value calculated. So using your calculator, we got the future value of the car is equal to 10,423.9 103,101. However, since we need to leave our answer to the nearest dollar, the final value of the car is $10,423. Then question C. Okay, so we have extra information here. So when the Darren has owned the car for n complete years, the value of the car is less than 10% of its original value, and then we need to find the least value of the n, right? So question C, the first thing that we need to consider is the value of the car after n years. So the value of the car is less than 10% of its original value. So the price of the car is less than 10% of its original value. So we have to do 35,000 times 10%, 0.10 to find the future value, right? The price of the car after n years. So this is equal to 3,500. Okay, and we do know that the present value, again, this is after first year, right? Just at the start of the second year. So present value is equal to $29,750, right? And interest is again 11% is decreasing. And what we need to do is we need to find the m value. So once reached this point, you can solve this question using TBM solver, like the question B, or you can use the compound interest formula. Okay, you can find the compound interest formula in your formula booklet. So you can find the compound interest formula on the topic 1 on page 2 of your formula booklet in section 1.4, and this is the formula that we're going to use. Okay, so we're going to, the compound interest formula is FB equals future value times 1 plus interest, right, to power of k. Okay, this is the compound interest formula. So for this question, I'm going to use the compound interest formula to solve it, because I already shown you how to use the TBM solver. So future value is 3,500, and it's greater than the future value times 1 plus negative 11% to power of k. And the k here is same as n minus 1. The reason why we have to do n minus 1 is because we are trying to exclude that first year that has a different interest, right? Then we can say 3,500 equals to 29,750 times 1 minus 0.11 to the power of n minus 1. 1 minus 0.11 is actually same as 0.89, right? So this is same as 3,500 over 29,750 equals to 0.89 to the power of n minus 1. Okay? Then using the logarithm rule, we can say this is same as log 0.89 n equals to n minus 1, which is same as n equals to log 0.89. Okay, just writing the numbers out, plus 1. Then when you do this calculation, since we need to find the least value, right, with the m value is equal to 20.